Okay, well, it's good to see everybody. Good to be with you. This is the April TSC meeting. This is open to all, so don't be put off by that TSC. This is open to anyone who wants to join, share an integration you're thinking about, or learn more about what's happening in the project. And we just call it the TSC. We have an in-depth presentation. So I'll just cover the regular stuff that we normally do up top and then hand it off to Mache, who's going to be doing that presentation. So let's get into it, shall we? Um, okay, reminder, this meeting is recorded and archived on the wiki over at the LFAI and Data Foundation, our umbrella foundation. And here's our updated roll call slide of the current voting members in the Technical Steering Committee. And here are our communication channels. Yeah, we don't have much going on at Blue Sky, so if someone wants to adopt that channel, get in touch. That's a new one. And recordings are put on the YouTube channel thanks to Shiri, who's on the call for handling that these days. All right, let's do some intros before I get even further in. Here we go. Um, let's see here. Hope folks don't mind if I keep sharing the deck. Let's see. Up first, I'm going to put folks on the spot. So, Luke, I'm going to just ask you to introduce yourself briefly, if you don't mind. Tell us, just a little bit about yourself and why you're joining us today, if you don't mind.
Yeah, sure. So I'm an implementation engineer over at Atlan. So I have been primarily helping implement Spark OpenLineage for our various customers. And yeah, so I'm mostly interested on the Spark side. I think the OpenLineage project is a really cool project to be a part of, and uh, it was a lot of fun making my first pull request. So I'm looking forward to collaborating more and getting more involved.
Yeah, well, like I said, it's great to have you, and I'll be talking about your PR just very briefly in a few moments when we talk about the recent release. Great to have you. Moving on to Mache.
Hey, I'm Maciej. I'm a software engineer at Datadog, and I have a presentation today. Yeah.
Yeah, thanks. Yeah, noticed all the slides that are in the deck. Thanks. Looking forward to that. Um, Next up on the list is Shiri.
Hello, I am Shiri Cabral. I am a product manager at Capital One Software, and I have been an Open Lineage contributor for a while. So I mostly kind of work in the let's make an example for this, or let's make a proposal for that kind of space. So no particular interest today, except for knowing what's going on.
Yeah, thanks for joining as always and for your contributions. And then Tomasz.
Hi, I'm Tomasz Nazarewicz from Getting Data, OpenLineage committer, and today I'm mostly to just listen, and as a particular field of interest, it's mostly Spark integration in OpenLineage.
Cool. Thank you for joining as always. And my name is Michael Robinson, and I've been contributing to OpenLineage for a few years now, mainly on the marketing side and the foundation side of things. Okay. Quickly, here's our agenda. We've got a recent release to go over. A lot of stuff in that release, actually. And then a presentation on open lineage context by Mache. Okay, and then open discussion if you have any items in there, or for that section, I should say. just let us know. You could put it in the chat or wait till that portion of the meeting. Okay. So moving on to the most recent release since our last TSC meeting. We've got with 3612 in the Java client, we've got a fix. The client was producing the wrong data set namespace and name for this particular kind of Oracle URL. 3625 extends the DBT integration to support the DBT glue adapter, which will allow users who use DBT with AWS Glue to track their data lineage through OpenLineage. And it follows the same pattern as other supported DBT adapters like DBT Spark, DBT Athena, and so forth. 3605 in the Python client, this creates a CLI for the facet generator, which allows users to generate facets directly from the command line. 3572 adds a new object field to the parent run facet called root. It's an object that stores the run and job information of the top level parent run, regardless of how many levels deep the child run is nested. Moving on to 3622, for run chain, you've got your Airflow DAG, Airflow task, Spark application, Spark execution. Now we'll send all related events to the same partition to preserve the event order. And this is enabled by a change in 3572 that I mentioned before. And this includes necessary conditions and tests for the use case. Moving on to 3624, kind of a similar change here for a run chain where you've got your Airflow DAG task and then a custom Python script. Now all related events are sent to the same partition to preserve the event order. And again, this is enabled by the change in 3572 and includes all the necessary conditions and tests. Thanks to all the contributors, including a couple first timers. So Luke, and I'm not going to attempt to pronounce that. I'm not going to do that. But you're, very welcome. Thank you very much for your contribution. All right. Okay, so I'm going to get out of the way and let Maciej take over. Do you want to control the slides, or what do you want to do?
Yeah, let me show the slides. I just need to find the right tab. So what I want to talk about today is kind of the other mental model, the other use case that we have when we think about OpenLineage. And to introduce this concept is usually when we talk about OpenLineage and Lineage in general, our visualization is something like this, right? So we have some data on the left, we have some tasks that process them, then we have another output data, then we have maybe another job, maybe some other data set, and we think of like data pipelines this way. But usually there is slightly something more happening. And usually we have some processes that schedule, orchestrate all of this happening, right? So in this case, we have an Airflow DAG that has some Airflow tasks. And the Airflow DAG is actually scheduling the task that processes the data from the Snowflake to Iceberg, and then some other maybe intermediary task is scheduling the Spark job that processes the Iceberg data and puts it back to Snowflake. That's just a fictitious example, but usually that's how the data jobs look like. So maybe as a more context, the jobs get broken, right? So we have this Airflow, Spark jobs, and the job completes, but some downstream data quality validation job fails, right? And we can't see that the root cause was actually in the Airflow if we do not have lineage, right? It connects all these data systems. We not notice that something like it's changed to summertime as the Airflow DAG schedule, and the last hour was not processed. But yeah, and we can visualize that hierarchy as something else like flame graph here. So what we can see here is we have this Airflow diagram, then we have Airflow task, and then it's maybe spawn some DBT application. DBT application has a DBT model, and DBT model runs multiple SQL queries. And one of the DBT adapters is Spark. So you can run this chain of Airflow to DBT to Spark and capture this information via OpenLineage, right? OpenLineage right now allows us to capture this information. What's the job hierarchy, this vertical view of lineage rather than horizontal, via parent run facet. So for a given run, we are attaching a specific information that specifies which run spawned this particular run, right? So we have current run and we have parent run. But this is not magical. We need to pass this information somehow. So in this like flame graph, we can see like we have those different systems, and those different systems communicate with each other. And when we spawn the DBT application from Airflow, we need to pass the parent run information, right? And when we spawn the Spark application from DBT, we also need to pass the parent run information for that correlation to be happening, right? Otherwise we won't know that the jobs are connected at all. And we do that by passing in various means, right? Basically, we either pass some environment variable with the parent run information, or if we are configuring the job directly, for example, like Airflow to Spark, then we actually put the configuration in the Spark job, right? So we use the Spark configuration to pass this information, right? And then the child job reads this and attaches it to their events, right? But this has some limitations, right? And the immediate one is that we capture only the immediate parent run, right? So if you want to track what actually was the root, what actually spawned the whole chain of events from the Spark job that's in the end, we need to hop over each of these events, right? Each of those runs, and we have deep hierarchy. We need to do multiple hops, right? So it's difficult to trace the deeply nested run back to the original run. So we have to traverse this recursively, and if we have some backend that maybe processes this, we have to do multiple of those queries to some, for example, key value store, right? And if we want to visualize those graphs for a given like Airflow DAG, we have this Airflow DAG, but what we need to do is we need to actually check all of those tasks and to see which one has the parent ID, right, for the Airflow DAG. And then for each level below, we have to check again and again until we find all of those relevant runs, right? So for this, we have found the solution. Basically, it's to contain parent job information. So we do not only contain reference to the nearest parent job, we also contain a reference to the root job, which is visualized here as this blue arrow. And this, in the facet, it looks like this. So we have a direct reference to this root parent run. We can eliminate those recursive lookups because we always have this information attached as the root job and root run here in the parent root facet, right? So then we can do this efficient querying. And the inspiration for that concept is from tracing, from OpenTelemetry Trace ID. It looks and acts very similar, but we also have additional this drop information, right? And the same we have to do is propagate. So going back to the slide, we need to pass this information also, right? As we're passing the parent run information. So this is also already released in 131, as Michael said. Support for Airflow is coming soon. The PR is already ready. So this chain from Airflow to dbt to Spark will be working as soon as that gets released. And that's done. What's not done is maybe some other questions that we might have about this structure, right? And we have like Spark job, Spark application, but we maybe want to see what Airflow job, Airflow tasks spawn this execution particular. We can see the trace, like we can see the Airflow tag, but if the tag is very large, for example, and spawns multiple other jobs, we are not sure, right, which one spawned the task, the Spark app. And the solution would be to go back to this upwards traversal, and we will find the Airflow task that spawned it, but we are again need to do more computation required. So maybe the solution is just to pass Airflow cascade, right? If we pass the parent information, maybe want to pass more information, but it's getting complex, right? Because we're now passing multiple different values, right? We want to pass parent ID, we want to pass maybe some config, we want to pass Airflow task ID. So what's the mechanism that we want to do? And I think passing it via separate environment variables is not the right way, because we kind of end up with this envar hell. So my proposal is to have like a more flexible key value context and propagate this context across lineage runs. So like this is again inspired by tracing concept. OpenTelemetry has a baggage, and the baggage is something that gets passed in the context of trace, right? So here the mechanism would be similar. So we would have some key value object, and we would pass it as a single end variable, and the subsequent run can attach more information to it, right? So in this case, Airflow task run would add this task ID information to the context, and then the dbt, as it's spawning the Spark application, pass the context again to the Spark application. And to make it better, we should standardize the context values like the Airflow task ID, and this is also what OpenTelemetry does. So there is something called semantic conventions, and then it's as its name, conventions. It's not like strictly enforced. Similar to our dataset naming, right? So we have a convention about how we name the datasets, and we need to be compliant to basically have the lineage link, right? Just as in this context, we need to have good parent run information to be able to connect to those parent runs. And if we standardize something like this, we might simplify the correlation and have more context across deeply nested workflows. And if we have something like context, we may be actually directly integrate with OpenTelemetry to capture the OpenTelemetry context that may be at some root level spawn some job that is instrumented by OpenLineage. And how do we do that? I don't know. This is an idea. We can capture the trace, propagate the context, and we might have a specific facet, might be more general facet. And this would enable to have better correlation between lineage and some other application traces. And people could use this to automatically visualize data lineage in tracing tools. So this is something that would bring OpenLineage closer to the rest of the observability ecosystem. Well, I guess that's it. Thanks. Any questions?
I think from Atlan side of things, that this could be one of those gnarly situations that could help integrating with OpenTelemetry. I don't know, Luke, if you want to add anything, but this is something that we are interested in understanding a little bit more, ensuring that the observability part of OpenLineage is captured and solved at scale.
Yeah, I think there's a lot of need for this in the field where like a lot of child processes get spawned essentially, and knowing where upstream, not only like horizontal lineage, right? We know where data sets and data is moving, but also having that operational vertical lineage like you were just showing, I think is definitely a commonly requested thing in the field. So this is good stuff.
Yeah, the biggest pain point we have from an OpenLineage standpoint with our customers is like, hey, did we not capture lineage because where did the failure happen? The event is not generated, the event did not pass the network traffic, or it lost somewhere, or like that is definitely a biggest pain point we have when we are chasing our own tail with bigger enterprises all day long.
Yeah, understandable. So if you manage to, something that we can help in open source, that would be, great to see. More details about those problems. Is this happening in like Spark integration mostly, or?
Yeah, so I guess one example is so a latest issue, not to derail too much if we're wanting to discuss other things, but just a TLDR is I'm seeing this scenario where the customer has a really long and complex PySpark job. So it's doing a lot of transformations, it's doing a lot of joins, self joins, like joining back to data sets or data frames. And so I think it's producing a really large logical plan. And uh, I haven't been able to identify where the issue is going wrong, but we're essentially missing some events, and I'm not seeing any like warns or errors being thrown in the logs, but we're not getting like a complete event. And when I'm trying to reproduce it, I'll actually sometimes see those events and sometimes they're not coming across. So I don't know if there's something I'm in my local environment I'm doing wrong, but it's a little bit difficult to pinpoint this issue.
Yeah, I mean, we might go just to open discussion with this. I think there are a few possible reasons. One is memory consumption, right? And in the past, we've seen some memory issues. I think they were mostly fixed from what I heard from people who had this. And as far as solution, we had an idea to kind of split the event generation part in few phases. And first is do this maybe simple, logical controversial, right? And capture the just the table level lineage, for example. And then if we have this, we can emit this and continue going further, capture column level lineage, which requires more traversal over more attributes, right? And generate column level lineage and transformation types. So this would also help, I think, with debugging because we would see where the issue is happening. Another, I think, issue is that Spark has a giant ecosystem, right? And there is few hundred, I think, logical cloud nodes with various versions from Spark 2. Now we are going, I think, with Spark 4 into production, right? And we need to handle all of this complexity within like one application. So yeah, I understand that finding a specific issue is not the easiest.
Yeah, that makes sense. And again, we can probably take take this offline. Maybe I can post something in the Slack channel. But I think typically when I'm reproducing a Spark issue, try to pinpoint it to like a smaller set of code to reproduce it, and then you can create like an integration test, and then step through the debugger to find where exactly it's going wrong. But I think with this issue, it's hard because I think the issue is only happening because the script is so large and there's a lot of complex things happening. So yeah, I think I'm at a loss on what the best practices are here to try to find the issue.
I mean, it would probably be helpful to know the logical plan, right? First, and see what actual visitors are being used. Because I think this narrows it down a lot. And
Sure.
second, try to disable column level lineage and see if it happens without column level lineage.
That's a good point. Actually, is that on? I've actually never done that before. Is that a Spark configuration to totally disable column
Yeah.
level lineage?
Let me.
Okay. Because again, hopefully it's okay that we're a little bit rabbit trailing here, but one other thing is I'm seeing, and I'm not sure if it's related to this missing event issue, but I'm seeing like I have the data set lineage enabled so that it breaks out the column level lineage into the fields and data set. And I'm seeing under data set some like duplicate transformations. And I'm not sure if that's a different bug or issue or if this is, related to the other issue. But yeah, so I'm seeing a few things.
I think Tomasz here would be the best person
Yeah.
actually.
If you have
Yeah.
if you have the duplicates in the dataset dependencies, then I think that would be the best to just we can talk offline about the logical plan, because like the best I can say, it should not happen.
Mhm.
They are the duplicated, and well, that just seems like some edge case that needs to being looked into individually.
Yeah. Would the best place to reach out to you async, would that be just on the OpenLineage Slack channel? Okay, awesome. And one last note on that. The facet, it's just like it shows like indirect, and then it has like a couple other attributes like the join type or transformation type, and then it has description as one of the attributes. And I'm seeing description as an empty string and then just a bunch of indirect transformation types. So that's why I'm considering it a duplicate. I don't know if it's just missing metadata or if it truly is a duplicate, but I can share that offline and we can maybe talk about it.
Yeah.
But I guess ultimately to do like a quick test, and I'll probably honestly do it after this meeting, is you can disable the column level lineage, and that should help kind of rule out if that is affecting things. Okay, cool. Yeah, try that.
Also, on the point of separating the column and dataset level lineage, do we because I don't think I'm very much aware of that magic. Is that in a separate event, or is just separate generation, and in the
It
end
doesn't exist. It's an idea, right? So
yeah, but like you you spoke about it as if it was thought out. And what's the idea here? To send multiple events with just dataset and dataset with column level, or?
I think the best way would be to have a hierarchy like we had here. But yeah, something like this, right? Separate events, probably.
Okay.
Yeah, so that's actually another question I have is where could I go to learn more about how events get produced? So like I kind of understand the start and complete, but I'm not sure I understand why we get multiple or sometimes zero running events, at least within Spark. I don't know if you have like a short TLDR, or if there's documentation I could look at for that.
I think this is purely when we have more SQL jobs, right? So that the job hierarchy in Spark is like you have SQL, the application level event, right? And then you have possibly SQL level event that doesn't happen, and then job level event. And that depends whether you have RDD job, which doesn't have the SQL event, and you should not get the running event there, or whether you have Spark event, and then we emit running level event for those. And the reason why it's done this way is at some point, some logical plan nodes were not captured when we used only the one of those, right? So either job or SQL. So we decided to use both and capture more information and then emit it as running if we have both. I think that was somewhere in like 2022. And I don't think there, I would be pretty hard to find a relevant discussion right now, I think. Probably it's documented in the pull request at most.
And Luke, I put a more general resource in the chat in case you haven't seen that.
Yeah, but sure. It's just
I can read over that as well. I think it's I need a better understanding of the logical plans and the different ways OpenLineage parses it. I'm still just starting out, so I don't really have a Java background either. So I'm definitely leveraging AI to help me learn the source code. But yeah, so just another thing I need to dive deep into and learn.
yeah, this is like relevant part of code. The thing is we are committed to having only one complete event, right? So that's why we limit running them.
I'm not seeing the where's the column lineage configuration that you can, the Spark config that you can disable?
Yeah. We'll look for it later. Okay.
Okay. Sounds good.
Isn't it just disabling column level facet?
Maybe. I'm not, not the best place maybe to do live code search right now.
Yeah.
Okay. Any other open discussion topic? I guess we finished early today, Michael.
Yeah,
Thanks.
sounds good. Thanks, everybody.
Thanks,
Great
everyone.
presentation, Marcia. It's very good. Thank you.
Yeah, thanks.
Okay.
See you in
See
a
you
month.
next time.